Hi there. I'm Kevin.
Hello, everyone. My name's UcheAdegbite.
So we're gonna kind of tag team this. I'll do a little bit from the beginning, and then Uche will take over in the second half. Just to give you a little bit of background on myself. I'm a data and AI specialist with Microsoft, and I cover everything. A little bit higher. Is that better? I cover everything from on-prem SQL Server to all the data services, 50 plus platforms and services and APIs in the cloud, to Azure Machine Learning and ML Studio, and I'm supposed to cover most of them in technical depth. And I'm really pretty much an expert in all those technologies. So that's the best I've got. Come on, work with me here. Nobody's an expert in all those technologies, but I do have to cover a lot of them in technical depth, and just enjoyed to be sharing the stage with Uche here.
And I'm part of the Azure Global Government AI and Machine Learning Group. I focus on cognitive services, and I specialize in the speech and language area, but we cover everything.
Great. So I'm going to cover knowledge in general, a little bit about AI and knowledge mining. Thank you. If I have it down here and you can't hear me, just have me bring it up, okay? I'll cover a little bit about knowledge in general and some of our cognitive services and how we use AI and cognitive services. And then I'm going to turn it over to Uche, and she'll cover...
Yeah, so more of in when we talk about our end-to-end solutions, especially in the enterprise space, or what we can do, what we can do with cognitive search in particular. So I'll walk through that.
Right. So we joked about the cookies.
We sure did.
A little bit, and I hope you do get a chance to try some of those in the back. We cover knowledge from a standpoint. Am I in the way of the screen? Just make sure I'm not. So I like to start with a definition, a working definition of knowledge when we talk about knowledge mining. And for me, knowledge is an interactive relationship that empowers us to take intelligent, responsible action, right? And so what does that mean, right? There's a lot in there, and what do I mean by interactive relationship? And I was sharing this definition with Uche, and I said, I use a cookie to demonstrate and talk about what that is. And Uche had this idea about
brilliant idea
about having a bake-off.
Correct.
So I said, okay, bring your best, and we'll make some cookies, and we'll let the audience decide who has more knowledge about cookies. So we're going to put you to test that, but let me unpack this a little bit, what I mean about knowledge. So now, who has already had a cookie? Has any? Okay. So this might not work for you, but if you haven't had a cookie yet and you saw that image, it's probably eliciting a response. Your mouth might be watering, right? You might have an emotion evoked related to, say, your grandparents or something like that, a time when you made cookies. And all of that is based on your knowledge of that image, right? And what is packed into your brain. So let's say, because you know what a chocolate chip cookie is. You have an interactive relationship with them. Let's say if I could take somebody indigenous from, say, the deep jungles of Brazil, who has had no experience whatsoever with cookies. They don't have any context for what a chocolate chip cookie is. And I showed them that picture. Do they know what a chocolate chip cookie is at that point? No. Who said no? You got the answer. Whoever said no. Yeah, they understand what an image is of a chocolate chip cookie. They've attached a label to an image, but they have no context. Is that as big as a house? Is it the size of a pinhead, right, that's been expanded? They don't know. So let's say I now bring them into a room, and I put the chocolate chip cookie on a table, and I bring a child out, and now they have context, right? So at least now they say, okay, I have dimension, I see size, so I know knowledge there, I have information about that. And now let's say they see the cookie, the child picks it up. They don't yet know if is this a weapon, right? Is this something the child's going to play with? What is it? Right, and the child takes a bite, and just pure joy comes out. And now they know the child's eaten one of my cookies, and
Uche's cookies. But carry on, Kevin.
But now they know they have context, right? It's something that a child eats, right? They think it's something that's enjoyable to eat, so they know a little bit more about a cookie, right? And so you can carry on that analogy for a little while, right? And let's say you know more, someone who actually bakes cookies, and in all honesty, I did not bake those. The contest was households, so
You cheated.
I cheated.
Okay.
And
Because
I cheated.
folks, I actually rolled the dough and made my cookies. Just saying.
I showed up and was told, "Don't touch them." That's how it went with me. But if you've baked a cookie, right, you have more knowledge about cookies than somebody who doesn't, who has never baked a cookie. So it kind of works that way as you start to work through it. So what's that got to do with AI? Well, AI, when we think about AI, we think knowledge representation and reasoning. Those are kind of the two words that you see working around AI. And knowledge representation, we could talk about understanding, and it's taking information in our 3D world that we're used to working and representing it in a ones and zeros type of context. And then reasoning is the ability to use that information and make decisions on it, right? And many times it's actually impartial information, right? So what are these people doing here when we talk about knowledge? They're actually doing knowledge mining. Now, you don't see it here, but Uche and I met with them last week and gave them our cookies, and they're saying Kevin's cookies were really, really good. In fact, they're the best cookies I've ever had.
I object. Okay. What they're really, remember how the conversation really went. What they were saying was they tried my cookies, and they understood that I know that what makes good chocolate chip cookies are the quality of the chocolate chip.
No, it's
that's what they were saying.
No, it's the amount of chips, not the quality of the chocolate chip.
Let's just, in the spirit of neutral judgment, let's just ask.
All right.
Let's just ask.
So invariably, hey Siri, which is more important, chocolate chips or the quality of chocolate chips, the amount or the quality, right? And so obviously we're not paid for our acting skills, but you get the point, right? We see this kind of conversation happening all the time. You have organizations that are filled with workers who understand knowledge mining. They're used to doing knowledge mining. They do it all the time. How many people in the last week have gone to a search engine, Bing, that other one, and used it to look up information in your normal world, right? Or you asked your phone. Raise your hand if you've actually done that in the last week. So everybody does that. It's part of our culture. So your organization and agency are filled with people who know how to do knowledge work. They're not knowledge workers, but they're filled with it. The problem is that your data is not sitting up in the in Google or Bing, right? Your data looks like that, right? It's and whether it's figuratively or literally, right? Your data is sitting in unstructured piles of information, whether it's spreadsheets or emails or PDFs or TIFFs, etc. And the second problem is those are the only people in your organization who know what's in there, right? They don't scale. They take vacations. They switch jobs, right? They're not accessible, or they're answering the phone for all those other people who are trying to get access to that information and they know they're the go-to person, right? So that's the problem. So when we talk about a knowledge mining solution, what we're talking about is taking that data, right? We're ingesting that data, and Uche is going to cover it in a more detailed
Correct.
selection. I'm just looking at it from a high level here. We're talking about taking all that kind of unstructured data, and statistically, researchers say that about 80% of your data is unstructured, right? And that your knowledge workers are spending, or I should say wasting, over 25% of their hours trying to find what's in there. And ultimately or most often are not successful. That's why they're spending so much time. And we're gonna actually enrich that data with our cognitive skills. And I'm gonna drill down into our cognitive skills to show you how we take that unstructured data and what kind of techniques from an AI perspective we use to enrich that data. And then we put a modern human interface, and Uche is going to cover the whole pipeline in terms of how we do that to show you how it works. Okay? Thanks. So let's talk a little bit, before I dive down into some of the skills, let's talk a little bit about Microsoft's approach to AI and cognitive services. And there's different ways we cover this. I like to start, I won't start from the top, I'm going to start from 3 and 4, or 3 and the last one. And the reason I'm going to start there is because I'm in sales, and I have a software engineering background, and I can't build anything from scratch from an AI perspective. I am not a data scientist, right? I don't know my Bayesian from my Beijing. Did I say that right, by the way? Because she does, yes. By the way. She knows all that. So I don't know that. But if you need to build custom solutions, we've got all the tool sets to build any kind of custom machine learning or AI model that you want, and that you can employ it with AI going all the way down into the chipsets. And frankly, I can't process AI in the chipset. All right, come on. I can't process AI. Work with me, people. Work with me. Goodness gracious. Okay, so what do we do? What's our approach at Microsoft? Right, Microsoft helps people like me look like we're rock stars, because I can take pre-trained, what we call pre-trained sophisticated models, whether it's a vision model or a speech model or a language understanding model, right? And I can use what Microsoft has spent thousands and thousands of dollars or millions and millions of dollars, literally, with thousands of engineers building those models, and I can access them with a simple API. And any developers in here? Because I'm talking APIs. I want to make sure. Okay, so I can make a simple REST API call and send it some information and get back a payload, a JSON payload, where I can access that and get a result. And don't tell my boss, but it actually makes me look really, really good, because it looks like I'm doing AI when really I'm actually accessing somebody else's AI. And frankly, that's the only way that this is going to scale, because, sorry? There's more people like me out in the world doing engineering and programming than there is like Uche, who's able to do the data science level of it, right?
I just got graduated to a data science. Thank you, Kevin.
Well, I mean, she has the background and the skill sets, mathematically, to understand what's going on there. I don't. And you have to if you're going to actually do it at the lower level, right? And so in order to scale in your organization, these sorts of cognitive services where you can do simple API calls or take it to the next level and do a little bit of customization, and I'll show you some customization, right? So instead of saying, okay, I just want to identify something as a vehicle, and I have an example. I say, let me differentiate between a tank, a Jeep, and a Humvee, right? I can do some very simple customization and modeling and labeling and be able to tell that. So that's why it's really important. Thanks. So we've divided up our cognitive services into 5 different areas. The labs is kind of not really an area. Yeah. What are we doing? And so we think about it: vision, speech, language, knowledge, and search. How many of you have seen some of Microsoft's cognitive services in action? Okay, so many of you have. So for you who have, this is going to be kind of a repeat. And I'm going to drill down into a few of these. I won't talk through all of them. The one thing that's new that most people haven't seen, we've got that second level of customization. On the third level, which is really important to a lot of our government customers, is containerization. So for instance, if you've got data that you don't want going to Microsoft and you want to run it in your own virtual network, you can containerize a model, for instance, send images to that model and get data back, and the only thing that's going to Microsoft is a meter saying that it was used. None of the data actually goes, right? So it all stays in your local enclave, which is a really powerful thing. Right. So I'm going to go through a couple of these from a demo perspective, and just to show you what they look like, and then Uche is going to show you how they actually work inside of a knowledge mining solution. Okay. So let's see if we can swap off here. I need to put this on. Okay, so for us going screen, duplicate. And let's pull up the intelligent kiosk. Well, we already got one in there, so let's go back. I did the reveal before I started. Bad. Never supposed to show the punchline before you get to the joke, right? So, okay, so we're going to take a look at vision first. And so what vision... No, it's all right. We'll take a look at custom vision first. And so what vision does, it allows me to send an image or a URL, and then it'll give me back different types of information that I want. I could get, tell me, are there faces in there? Tell me, broad taxonomies of I see grass or fields or things like that. And then you can even customize it to do things like I was talking about tank or Jeep or something like that. So I'm gonna select a photo that I've pre-selected, and this is just our ordinary vision. Let's see. let me go from local file. And you all know who this is, right? So this is Shaquille O'Neal dunking a basketball. And you can see it shows up there, and I can't zoom in here. Let me see if I got my zoom key set up. Control 1. Can't do it with two hands. So anyway, that says Shaquille O'Neal dunking a basketball, 98%. And it's actually doing text recognition, OCR, to recognize the numbers. And see, it says Horace Grant. This is going back a little ways, by the way, for basketball fans, and shows the various numbers. It catches the 5 on the 54 and the 32 on the side of that. And I can turn on object detection, and it'll recognize, and it's going to give in our JSON payload. It's actually giving back, where exactly in the image it's recognizing that. So it's seeing that we have a ball and a person and footwear. So that's a new object. That's part of our new object recognition within that. And then I'm going to do this same image. Actually, let me just do one other image while I'm still in Vision Explorer. And I'm going to show you another image of a particular vehicle. Okay, and we'll do that from a local file. And so this is a Humvee, right? But Humvee is fairly unique. So if I pulled up a dog, it's going to say a dog. It's not going to say the type of dog. In this case, it recognizes it as a military vehicle, but it doesn't know exactly what type. Our description that comes out of our API, you can't really see it. I'll read it to you. It just says a truck parked in the grass, and it is doing image recognition. So you can see, okay, it's reading this and saying, watch for approaching vehicle traffic and so forth, right? And if I do object detection, it's coming in there and it's saying, okay, it recognizes tires, and it puts my bounding boxes around my vehicle. So now I'm gonna take it down a level, and I'm gonna show you our custom vision. So what I did, we have a custom model for the sport of basketball, and I'll show you what that image looks like, the Shaq dunking image in a custom vision model, and I'll show you what my Humvee looks like. All right, so we'll do the same two images, but this time I've done a little bit of customization. Basically, I've taken images and lots of images and tagged them as basketball, hoop, jersey, or we've tagged them as these are tanks, these are Jeeps, these are Humvees. So I'll go into my custom vision explorer, and then we'll pull in the Shaq image, and we're using the basketball object detection custom vision. And you could do this with pretty much anything that you want that you need to search for your own particular use cases, right? So we'll open that up, and now it's recognizing jerseys, ball, jersey. It doesn't quite have enough of the hoop to tell that that's a hoop there, but I'll bet you that if we put more images and tag them properly, right? When we think about machine learning, it learns the same way you did as a child. You're basically someone who was supervised and saying, that's a dog, that's a dog, that's a dog, and pretty soon you got a hang of it as human, that's a dog. Well, it's the same thing with this, right? If I took enough of these images and trained it and said that is the hoop, it would start to recognize and say, oh, now we have a hoop in this picture. All right, so I did the same thing as I did this custom vision, and we talked about the Humvee. So I'll show you my model with the Humvee that I created. So that's custom vision, and then we'll switch to our vehicle type. And I'll pull in my Humvee image. All right. And so it's going to send that, again, all what's going on behind the scenes here is it's sending this image up into use my model on the cloud, and I could bring that to the intelligent edge, right? I could actually take that model, package it up in a container, put it to the edge, and run the same thing and never go to the cloud. Just run it in a local instance, let's say on the edge, right? And it here's coming back and saying it recognizes it as a Humvee. So that's kind of how vision would work. I'll show you another one. Let's show you translate, for instance, is another great. You want to just hold that for a second? Sure. I'd like you to hold it. I need your hands occupied because I'm going to show in Kevin makes the best cookies.
With the false information.
Uches aren't bad. Aren't bad either. Okay,
and folks, ethics is an important part of AI. It's something Microsoft believes strongly in. Thank you, Kevin.
Yes, I'm ethically
Honest.
The truth is, so we can translate this into any of 120 different languages. Does anybody read Urdu? There you go. Are we close?
Are we close?
Okay, so I'm assuming that's what it says, that Kevin's cookies are the best. So we.
And if he doesn't get that, then yeah. Wow, thank you.
Very good. 'Cause I wouldn't know. I'm just trusting you.
Thank you.
So very good. And I have one other demo we'll show you. For this one, I do need a little bit of support. So I'm going to drop this down. We'll pull up a video here. So this demo is one this is a use case that we actually just ran with. We did a mock trial with Navy JAG in Williamsburg at the College of William and Mary. And so this is our speech to text. Right, so it basically is taking audio files, and we were able to capture 2 to 3 hours of audio, and within 20 minutes we had back a full transcript. So I'll just give you a little taste of what that says. Now, this was captured in stereo, so we're not able to play it through our system. So we're gonna have to use the old-fashioned way here. All right. We played it through the speaker system, and unfortunately it was just one channel. So in order to get both of them, we're gonna have to do it this way. Oh, wrong one. That is a video.
Did you see a scene where 2 men were in a bar and something that followed?
I did, yes.
Can you describe that situation?
Sure. Basically, I was sitting there minding my own business, perusing through a brochure that I had picked up and drinking my beer, and all of a sudden there were these 2 gentlemen in a booth that started having an argument around, I believe, football. It's not my sport, being Canadian.
So hockey's his sport. So the reason the guest couldn't come here tonight is because the Capitals are playing Game 7. But so you get the idea. That's kind of the different technologies we can use, and that's pretty darn accurate. Coming from that's an untrained model, right? So and a speaker with a little bit of an accent coming through. So. We take all of that information, right, all of that knowledge, we packet it up, and then I'm going to hand it off to Uche, and as Uche prepares, I'll do tap dancing. She's going to show you how that all works from an end-to-end standpoint and how we use those services in knowledge mining.
Okay.
Hey, Kevin.
Yes.
What was the use case behind that? I mean, what was trying to replace the...
So that particular use case is that organization spends quite a bit of money, and it takes 6 weeks or so for them to get back a transcript, and that impacts the number of the caseload that they can manage. Basically they have someone taking an audio file and listening to that audio file and then transcribing it. And it goes back and forth with errors because they need it for the appellate review process, and they have a certain time window. So we've basically reduced their costs by a factor 6 or 7 probably, or more. And then in terms of the time, they're able to get it back pretty much instantly, right? But by the time the trial is over and they go have lunch and come back, or the day's case is over, they have it back. So very impactful type stuff. And that's why we do cover cognitive services, by the way, outside of just knowledge mining, because they do have broad application to other solutions besides what Uche is going to show you.
Correct. Thank you, Kevin. So earlier, Kevin walked us through our typical process, which is ingestion of unstructured data from different sources, and there's a very diverse set that Microsoft handles. We have images, PDFs, videos, audios, the likes, and multiple types of data sources that we're able to work with. And when we look at it, enrichment, this is where we're able to leverage our cognitive skills, some of which he demoed, as a way to be able to extract the latent intelligence from the data and create that structure that is more indexable and searchable, and we can actually surface that from different endpoints, whether it's a web front end or you can use it to do further analysis. So when we look at knowledge mining, this is the architecture that we follow. And a lot of our customers, this is a typical scenario that comes up. There's always this ask for the analyst or the people at the field to be able to find that needle in the haystack, right? And we need to be able to do this in an agile and a rapid manner. And most of the times this is life or death mission type situation. So what I'm trying to show here is when we talk about knowledge mining, these are the components that are involved, and I'll walk you through and then go into the individual steps, what they really are. So here, at a high level, what we're really saying is you take the unstructured data from multiple data sources using document cracking, which is our process of being able to extract the metadata using a specified index schema out of said collateral that's unstructured. We then prepare that for our cognitive services pipeline. And in here, it's an extensible, customizable pipeline like he's alluded to, where you basically get to select the different types of skills. We call them skill sets, but they're really the different services that we offer in Azure Cognitive Services to enrich the data and provide that metadata that enables you to make your searchability and structure the data in a way that enables you to find that data in a more rapid manner. And so that data gets indexed, and we can highly make that visible through Azure Search. And in the demo I'll show you, we have a front-end UI, but you can imagine it can be part of your services or application. So what exactly is document cracking? Basically, it's our ability to be able to go through the different data sources and assess all these different file formats to pull out and index the data according to a specified schema. Now, you can imagine that if I'm, I'm an analyst, and in our corporation, we're continuously getting data coming in from the field in different sources. We're going to have this, we're going to probably create an Azure function and have our pipeline running continuously so that as I upload new data, I'm always being able to get that intelligence extracted through this pipeline and surfaced at our endpoint for the analyst to do what they need to do. We pretty much, any kind of data source is indexable here. I've listed some of the few that we use, and you can see that just the diversity of format types that we support. And so once the information has been extracted from the different file formats, we have these cognitive skills that are already built into cognitive search. And you can see a bunch of extractions. Like we're able to, extract organization, location, people, places information. This is really part of our text analytics suite, if you will. You talk about the face detection or celebrity recognition, which is what Kevin has demonstrated as part of his Shaquille O'Neal section. But you also have the ability to create custom skill sets. So you can imagine here that, if I have a specific, to what Kevin was saying, I need to be able to specifically identify a Humvee, which is a type of vehicle. I can create a specific custom skill set that is computer vision model that is able to accurately identify a Humvee. In the case of the demo, I've created 2 custom things, so you'll be able, I haven't created it, it's part of the demo, but we've leveraged 2 additional custom skill sets to be able to complete our scenario end to end. But yeah, if you want to be able to build a skill set from scratch, we also provide that platform through our machine learning VMs or any open source that you could also use. So a sample skill set, and this is actually like detailing the flow of how we've built our actual demo that I'm going to walk us through. But for this demo, we focused on images, and it was mostly content from PDFs, and it was mostly images and text. So for the images, the way that we applied, the cognitive skills we applied were mostly in the optical character recognition front, where it enables us to be able to go through images and extract text, whether it's printed or handwritten, and based on our schema that we had written, identify the exact terminology that we were looking for and display it. However, we're also able to use our face and celebrity recognition APIs to be able to also analyze who is in those images. And then what we do is we merge that with the text, and then we apply a lot of our text analytics extraction type skills to be able to ensure that we're pulling out all of these relevant entity types, and so that we can more easily navigate through the relationship between these entity types. What you'll see here is we created 2 additional custom skills. A cryptonym extraction, because it turns out a lot of, in this scenario, in the government, there's a lot of code words used. And so in order to be able to understand the information, we needed to have a way to identify wherever the synonyms or cryptonyms were being used, that people could actually extract the actual name or search term that they were looking for. In the case of redactions, it was just fun because we tend to get a lot of documents that have redactions in there. We wanted to be able to surface those, just to see what's going on if we could. So yeah, those are the two additional we added. So I'm going to walk us through our actual knowledge mining demo, which actually is our JFK demo. And it gets a little serious here. I have to set the scene. Okay. I may need your help to hold this. Okay. On November 22nd, 1963, the President of the United States, John F. Kennedy, was assassinated. While driving through the streets of Dallas in his motorcade, he was shot by a lone gunman named Lee Harvey Oswald. By the way, this is my persona for analyst. At least, that's what the government wants us to believe. In fact, this has been a subject of so much controversy that 25 years ago, an act of Congress mandated that all documents related to the assassination be released by 2018. So they've released close to about 50,000 pages spread across thousands of PDFs that were declassified. Are you curious to see what's inside? I know I am. That's a lot of reading, so we're not going to do that. Of course, we're going to use cognitive search. Thank you, assistant. Okay. I try. Okay.
Do you want me to hold it?
Okay, thanks. No, I think I could type with one hand. It's just be interesting. Okay, so setting the scene. Okay, so if you've seen the JFK demo, pretend you haven't, because I added that skit so that it would be different. Okay, so what you have here is what we like to call our JFK demo, and this is a front end. I should probably take this off because I can't actually see. It's our front end UI, which in the back end we've built the cognitive search pipeline. So I'm going to go ahead and start searching. So we have actually got the 50,000 pages. That's all real, and we've actually applied our cognitive search, the whole pipeline I just described, on this data. So I'm going to walk you through certain examples so you have a visual and you can really see what I'm talking about. So let's go ahead and type Oswald, because that's really the person we're all talking about when we talk about JFK. So as you'll see here very quickly, when I start to perform, once I've done the search, there are 857 results found. And what you see here, the tag section, what we've done in the back end is we've actually used a lot of our extractions, if you will, under the text analytics to pull out these different entities. You'll see that there are names, there are people's names, there are organizations, the CIA, and there are locations. You've got New York City, Cuba. So right there, in like a split second, I already know that the CIA, FBI, and JFK are involved in this. So the good news is these are the right documents, right? So if you look to your right, you'll see that here we have surfaced some of the documentation. And because I had typed in Oswald, what we're doing in here is that using our optical character recognition cognitive skill, we're able to locate where Oswald is in each of these documents. And better yet, part of our OCR API actually surfaces the bounding box. It actually determines the location where Oswald was found. So when you actually go in, you can actually, we've actually added visual effects of putting hit highlighting and that highlighting on the first page so that it's easier to actually navigate and find exactly what you're looking for. So I'm going to go back to the main screen. Here is an example of what we talk about when we're saying handwritten OCR the ability to actually analyze handwritten images and text. So here, this is a handwritten letter, and using OCR, we're still able to go through the document, and quickly, as you peruse this, you're able to also look at everywhere that Oswald shows up. I want to bring your attention to the image. What you'll see in this image is no reference of Oswald, the name, but using our celebrity and face detection, which is part of our computer vision API set, we are able to identify that this is in fact Lee Harvey Oswald. And the other thing that this API will also return is analysis of what they believe is happening in the image. And that's why you see here to the right, we have added the caption here saying that Lee Harvey Oswald is posing for the camera, right? And it even goes as far as to be able to identify, and if you see if you look at the numbers as I hover over it, it has also been able to accurately also pull out the numbers in the I don't know what they call this thing, but the mugshot like sign thing, right? So again, just how quickly I'm able to find information about Oswald across different data types. This is the power of cognitive search. Okay, as I scroll down, if you see here, there is something called GP floor, okay? Didn't know what GP floor was until I understood cryptonyms. And it turns out, like I was mentioning before, the CIA have a lot of code words, and Lee Harvey Oswald's code name in a lot of communication that the CIA was doing was GP floor. So we did the only next logical thing, which is to build a custom skill that would enable us to be able to identify GP floor as a synonym of Lee Harvey Oswald. We added that to our cog search pipeline so that as we pass through the documents that we've actually cracked open, we're able to also surface up documents for GP floor anytime you search for Oswald. Okay, so of course, like I was saying, redaction's fun. So we were curious, and so we built a custom redaction classifier. I would love to say that I did, but here I got a proper data scientist because we actually had to use our Azure machine learning from scratch, and we were able to build a classifier that would go through documents and identify the dark from the low parts and provide a redaction score across all the documents and classify based on the threshold the documents we believe had redacted parts to it versus not. So I've been told not to really look at ones where you can really read through them, but the link is in the resource, so feel free to go ahead and peruse this in your own time. So these are the real files. And so let's go back to the tag section. So as I was doing my own investigation, I noticed something very interesting when I was searching for Oswald. I noticed that there was mention of Cuba, and I was like, what does Oswald have to do with Cuba? I had no idea because I didn't do any American history, so I needed to brush up. So I found out, my analyst hat kicked in, I found out that there were some, issues Lee had with the Castro regime, but more importantly, I believe there were some actual operations that the CIA actually were part of that had to do with Castro. So of course, I started to look at Castro operations, right? And already in document 2, I was like, oh wow, this is serious. Operation Mongoose. Operation Mongoose kept on showing everywhere, and underneath was anti-Castro activity CIA. But I'm super lazy. I wasn't going to read through all the documents. Lucky for us, we actually built a D3 force graph representation of the metadata that we're extracting as part of our cognitive services enrichment process. And from this, I was like, okay, Castro operation, something to do about mafia, pills, poison. It was getting very tricky. So I was like, wow, something seriously happened. So I did some further digging. And it turned out that the CIA hired the Chicago mafia to try and poison Castro with pills, right? So this is exciting stuff because, quite frankly, there's no way if I was just in the open space of that other search engine, but more importantly Bing, because Bing is what I use every day. that I would have made these correlations. But you can see here, like, the ease at which you can navigate through the nodes and be able to look at the relationships between the entities and deduce some, hypotheses, and then go and like verify them, yay or nay. It just makes the, finding that needle in the haystack that much more efficient. So of course, at this point, maybe this is like a couple of hours in, I did what any logical person would do, which is make sure that my name didn't show up in anything in this data set. Unfortunately for me, there was a hit. But don't fear. It said something about thanking Uche, so I quickly moved away from that. There was nothing of irreputable situation there. So, but I was, no, let's not go down this road, Kevin. I was hoping to say that I looked for Uche and nothing came up. That there was actually a hit, and that was a little scary. Of course, I checked to see what was happening for Microsoft, and after some searches, I realized that there was some documentation with SQL Server mentioned, and it turned out that they actually, way back in 1997, used our SQL Server to host said documents. So we were there in a good way as part of the CIA SCIF, really helping them to do their jobs, right? So again, this is just a very quick way to show the power of our cognitive search. Now, to what Kevin was saying, we have, the ability to containerize these services. So if you're thinking about the fact that you have your missions and you're in the field, we can also do a lot of this inferencing closer to the source of the data, right? So there's this opportunity to have this hybrid relationship where you're using cognitive services, extracting latent intelligence rapidly, and enabling your workforce to make the right decision in a timely manner. I'm going to switch back. Okay, so does that show up? Okay, so that was just a quick demo to show you the possibility of, when you're thinking from an end-to-end solution, how do we leverage all our different components to build something that is relevant to helping you extract latent intelligence for your specific organizations in a very simple way, right? A lot of this is using the pre-built models, and that was option 1 in the slide for our approach. And then really option 2, very little need to be a data science expert in any of this. So to summarize that, knowledge mining with cognitive search, it really is an easy way for us to be able to leverage our cognitive services on top of Azure Search to enable you to just create a lot of the unique solutions that you need across your different unstructured data set, right? It's a fully managed platform as a service, super easy to get on board. Azure portal makes it straightforward, and we'll also provide you with a bunch of the resources for you to play around with, and really check it out, because there's a lot of good stuff here. But before I leave, there's something, go ahead. Yes, I do. Not in this deck, but I can, yes. The question was, do you have a visual representation of the pipeline that was shown, the cognitive search pipeline? Yes, we do, and it's actually part of the documentation. Correct. Full access to that, correct. Before I leave, what I'd like to share is that at 11:44 a.m. this morning, as my partner here, Kevin, said, we had a bake-off challenge. I had the privilege to capture my bake-off opponent, sampling my baked goods. And of course, I did what any AI specialist would do, which is to capture the evidence, even though it was unstructured, crack it open, and run some cognitive skills on them. And so, Kevin, it turns out our face detection correctly identified you as Kevin Tupper. And more importantly, the sentiment analysis part of my cognitive skills clearly showed that I won. 99% pure joy is something I'm very proud of. And Just wanted to share that because that's very important. Thank you. Thank you.